let's look at what we have done last week. So all the information given here, 400 volt, 50 hertz, 4 pole, and 1370 RPM, and this is a delta connected. So in order to do the practice problem or problem for 3-phase, you must aware whether it is Y or delta connected. Okay, this is delta connected induction motor, and it has the following parameters R1, R2, X1, X2, and Xm based on this equivalent circuit. Okay, per phase equivalent circuit. And this is the phase voltage supplied to your stator. I1 is from the supply to supply for the motor, and and we have I1, I2, and this is the formula to calculate your torque. Okay, 3V phase squared R2 over S, where S is the slip and omega S is the synchronous speed. Okay, in this case for induction motor, you have two speed, which is the omega S, the synchronous speed, and omega M, which is the motor speed. Okay, so as you have done last week at start, the starting speed for the induction motor is 0 RPM. Okay, the synchronous speed is calculated by using this formula based on the frequency and number of pole. So this is the synchronous speed. And in order to calculate the slip, this is the calculation, and S, which is the synchronous speed, minus the motor speed, which is the rated motor speed, so the starting speed, which is 0, and at starting, the slip is equal to 1. V phase equal to 400 because it is delta connected. Okay, delta connected, always given in the problem if V line, but for delta connected, V phase equal to V line. So last week saya bagi silap formula ni, actually for Y connected, VL equal to root 3 V phase. So if it is Y connected, V phase will be equal to VL over root 3. So if you have all the value to find torque at the starting torque here, you put all the information in this formula. Okay, the difference between DC motor and induction motor, the induction motor you already have the formula to calculate the torque. So you put all the information in the formula and you get the value of torque. Berapa dapat torque last week? Ingat tak? Okay. So you dapat the torque at starting is equal to 102.54 Newton meter. So kalau based on this calculation, the motor does not meet the requirement of starting torque because T start is not equal to 110 Newton meter. So we can say that this motor is not suitable to run the compressor. But later we can change this and we can see what we can do. Okay, on the speed control later we can use this. So next we want to calculate the second calculation. Okay, the first calculation we have done the starting torque. Next we want to calculate for the starting current. Okay, starting current must be below 40 amp. Is it below 40 amp? So let's do it. Okay. So this is the per phase induction motor, and we want to determine whether the motor capable to meet all the requirement to drive a compressor. So this is the formula for the current, and this is formula for the Z equivalent. So the starting current, is it I1 or I2? I1 or I2? Starting current yang mana satu?
I1.
Okay. So your starting current will be your I1 because it from your supply. So how to calculate this? In order to calculate for I1, you must know V phase. Okay. You dah ada V phase kan? What's the value of V phase? 400. Yeah. 400 volt because
Delta
it
connect.
is, yes, delta connected. Sebo macam ni, macam you have to follow like this lah. Kita letak 400 but you must understand why you put 500. Delta connected, V phase equal to V line. Okay. Now, what about ZEQ? To calculate I, you have to know Z equivalent. Okay, so you use this formula to find your Z equivalent. Okay, so put all the values to find your Z. Boleh tak try calculate sekarang? Berapa? 80. Just use the formula. By the way, all this formula will be given to you. You don't have to memorize. Okay, kejap. R2 berapa? Okay, what about the slip? Kita ada value of slip here. Slip ni nak guna yang mana? Slip at starting. Kita dah calculate kan hari tu? Which slip you want to use? What's the value of slip at starting?
1.
Anybody? Dia 1 Kita dah calculate last week. Kalau yang belum tengok video, boleh tengok video. Okay. And R2 is 5/1 plus J 5 plus J 80. Okay. Slip equal to 1 at starting. Okay, so now put all the values. What is your Z equivalent? Don't forget to set your calculator. Complex mode kan ini? What do you get? So for your Z equivalent, you must have the magnitude and also the angle. Okay. Dah dapat? Tak apa, I give you the value nanti you calculate by yourself tau. Just nak save time. Okay, you dapat nanti akan 11.85 angle 57.23 degree ampere. Please check on this So now we want to calculate for the starting current and make sure it is below 40 in order to run this compressor. We want to know whether it's below 40 or not. So the starting current, okay, we're using this formula I1 over V phase over Z equivalent. And I1 V phase is 400. What about the angle for V phase? Do you have angle? So we put here 0 And this angle will always 0 because we're considering per phase. Always 0. So 11.85 angle 57.23 ampere. Okay, what do you get for I1? Which is a starting current. Okay, cepat-cepat please use your calculator. Saya tahu it's 8 AM class, but you have to participate. Okay, boleh start your brain tu. Macam nak start the motor juga, you have to start your brain slowly. Try to use calculator to calculate all these values. What do you get?
33.76.
Okay, you get 33.76 with angle?
Negative 57.23.
Negative 57.23 ampere. So, is this the current unit? Is this per phase current? Yes kan? Okay, so kita tengok dia, this is 40 and we know we calculated I1 equal to 33.76. So we can say that it meets the starting current because I1 is less than 40 ampere. So second requirement, you meet the second requirement in order for the induction motor to run the compressor. Are you okay up to here? Boleh kan? So we only apply the formula that available or given later for the induction motor. First, on the previous calculation, we have the formula for the torque. In this calculation, we have the formula for the Z equivalent and also the formula for the starting current. Okay? Can we proceed? So next. Ada orang ke ni? Tak ada orang ke?
Ada doktor.
Boleh ke?
Boleh.
Kan semua dah tertidur ni. Okey ke dengar suara saya clear ke tak?
Clear.
Clear kan?
Clear.
Bagus. Okay, next we want to calculate the third requirement. So it said that in order to run the compressor, we must have the torque of at the top of 48.3 Newton meter with the current below 10 ampere at motor speed 1370 RPM. So at motor speed equal to 1370 RPM, we must have the torque of 48.3 Newton meter and I must be below 10 ampere. So we want to calculate whether this induction motor meet this requirement or not. Okay. So what we want to do now? First, what we want to calculate? Okay, at motor speed 1370 RPM. What is this speed? Motor speed ni sama dengan speed mana ni? Okay. Sama dengan rated speed. Okay. So this is equal to Nm rated. Rated condition. So this speed is at rated condition. So now we want to calculate the TE rated. Alright. So which formula you want to use now? Kita guna formula ni lah. Okay. What about the slip? In this formula, kita ada the speed and also the slip. Okay, we have V phase. Dalam formula tu kita ada V phase. Kita already know V phase equal to 400 volt because it's delta connected. Now, the unknown value in order to calculate the torque is the slip. Okay. Berapa? Macam mana how to calculate the slip ni? Anybody?
NS minus NM.
So, slip at 1370 RPM S equal to NS minus NM over
NS.
NS. Okay. Berapa NS? How to calculate your NS? Kalau yang belum datang last week, NS is your synchronous speed. So you are calculating this by using this formula, okay, over P. Betul kan? So put the frequency equal to 50, or equal to 4. What do you get?
1500.
1500 RPM. Okay, this is the formula used to calculate your synchronous speed. And your synchronous speed can be in RPM or radian per second. Mana-mana pun boleh later you change lah kan radian per second. Okay, so to calculate the speed, 1500 minus 1370 over 1500. What do you get for your slip? New slip now at rated condition. Okay, you get 0.087. Okay, this is your new slip at rated frequency, rated rated RPM, okay, speed 1370. So how to proceed now? So we already have V phase, which is V rated 400, slip at rated condition. What about omega S here? What is omega S? Is it for the motor or synchronous speed? Is it motor speed or synchronous speed?
Synchronous speed.
Yes, omega S, your synchronous speed. Okay, you ada dah your omega S. So now to calculate the torque at 1370 RPM, you put all the value in this equation. So, boleh cuba? 400 squared R2 5 over 0.087. Okay, the speed is in radian. You change. Okay, R1 is equal to 2 plus 5 over 0.087 squared plus 5 plus 5 squared. Okay, what do you get for the torque? Please calculate. Berapa dapat? Okay, now the calculation. 49465. Tu tak ni? Yang lain? Semua value saya letak betul kan? Anybody? Yang lain? Dapat tak? Hello, saya nak tahu juga yang lain dapat berapa?
48.29.
Yang lain tolong check juga So jawapan dia 48.29 Newton meter. Okay, based on the calculation on the torque at 1370 RPM, the value of torque is 48.29 Newton meter. So it meet the requirement for the torque to drive the compressor. Lebih kurang kan 48.3 and 48.29. Kita boleh stop kat sini ke? Can we stop here? Or we have another requirement to calculate?
Current.
Okay, this only for the torque. Yes. So now we want to calculate for the current. So before we go to calculate the current, do you have any question on this? Are you okay? Boleh kan? So the requirement to calculate the torque, you have the slip here. And the slip is based on this formula where NS is the synchronous speed. Synchronous speed ni memang takkan berubah sebab dia based on the frequency and number of pole. But the speed of the motor may be berubah. Okay, at starting it is 0 but now at rated is equal to 1370. So kalau dia punya speed of the motor change, you have to calculate new slip in order to calculate for the new torque. Boleh? Okay, so next. Sekejap Nak calculate for the current. Alright. And next we want to calculate for the current. Apa yang formula kita nak guna nak calculate current tadi? Sekejap saya ambil formula daripada sini.
V phase over Z equivalent.
Mana formula dia tadi? Saya cari sekejap This formula. Saya copy. Senang nak rujuk kalau ada. Okay, this is the formula tadi. Okay, the same formula that we have used before. So, now, at 1370 RPM. Okay, we want to calculate the new input current or starting current I1. Okay, so we are using this formula. Okay, I1 equal to V phase over Z equivalent. So V phase you already know is 400 with the angle of 0. What about Z equivalent? Can we use the previous Z equivalent that we have already calculated? Or this Z equivalent will be different?
Different.
Different. Why?
Value
Why
of
it is
S.
different?
Value of S.
Because at 1370 you have new value of S which is equal to 0.087. So now please put all the values in the equation. Ini jadi difference. Yang lain semua sama. Put the values in the equation and start to do your calculation. Tengok dapat berapa Z equivalent? over 0.087 plus J5 over macam mana? Sorry dah over semua pula. Try calculate tengok. over 5 over 0.087 plus J5 plus J80. Okay, what do you get for Z equivalent? So, make sure you know how to use your calculator. Nanti exam, you kena calculate sendiri nanti ni plus. Okay, make sure you jangan buat any careless mistake. Do you get 49.25 angle 42? 060? Oh, dapat ini ke?
Dapat.
Sama. Okay. So this is the value of Z equivalent. So now to calculate the current, put into the equation. Okay, 49.25.06 ni. And you will get, berapa dapat ni? 8.04 angle minus 42.06 degree ampere. Macam ni ke dapat?
Betul.
Sama? Betul sama ke? Sama?
Sama.
Kenapa suara tu? Okay, so now the magnitude of I1 kita dapat dalam 8.04 ampere kan? So let's compare with the requirement of the compressor. The current drawn must be below 10 ampere with the torque of 48.3 Nm. So is this meeting the requirement? So it is less than 10 ampere. So motor kena letaklah calculation sikit kat sini. Meets all requirement. All means the torque and the current requirement. Sekarang kita dah calculate ini, dah meet all requirement. Ini pun dah meet requirement. Only for this, dia tak meet requirement. So motor meets all requirement except except starting torque. Okay? Except for the starting torque. Okay, so kita dah calculate. So the motor boleh run tapi except for the starting torque, it is lower than the requirement starting torque. So later kita tengok what we can do. Okay? So boleh faham tak up to here? So basically you have learned how to calculate the synchronous speed by using the formula NS over 220 F over P. And you also learn how to calculate the torque at different speed by using the formula. So in order to calculate the torque, you must have the synchronous speed and also the slip. And you learn how to calculate the slip by using this formula, and how to calculate the current by using formula V phase over Z equivalent, and how to use the formula for Z equivalent. Okay, boleh sampai sini? Boleh
Boleh.
Right, bagus. So next. Also, I have an extra question here. So in extra question, katakanlah dia the same question, the requirement, and is the starting torque required by the compressor higher or lower than the maximum torque of the motor when operated at 450 Hz? So sekarang kita nak tahu pula the value of maximum torque. Is it lower or higher? Yes, kita nak tahu T start ini, is it lower or higher than T max? Alright. So how to calculate this? If you go through in the notes, there is a formula on calculation of maximum torque and also the calculation for maximum slip and maximum speed. Okay, nanti kena go through into the notes. Go through the notes. So setiap induction motor, setiap motor ada dia punya torque speed characteristic. And the torque speed for the characteristic for the induction motor is like this. Okay, lebih kurang macam ni. And this is T start. This is T omega. Okay, this is torque speed characteristic. Okay, the graph for the motor. Kita belajar itu waktu kita nak masuk electric drive induction. every motor or each motor, either it's DC motor or AC motor, it will have its own torque speed characteristic. And this is the torque speed characteristic for induction motor. At speed equal to 0, starting kan, you have the value of torque here, the starting torque. And you also have the value kat sini, which is T max. Okay, the maximum torque, or is also known as pull out torque. Okay, maximum torque ni juga dikenali sebagai pull out torques. Okay, how to calculate this? Dekat T max ni, you also have this speed, okay, Nm at T max, and here dekat sini ialah Ns, which is the synchronous speed. Okay, synchronous speed dekat torque equal to, when torque equal to 0. Okay, so now we want to find whether the starting torque for this problem, is it higher or lower than the maximum torque? So now we have to calculate the maximum torque and compare. Alright. So macam mana kita nak calculate? This is the formula. We have already we know the synchronous speed and we know the phase voltage. Okay, phase voltage, V phase equal to 400 volt because it's delta connected. And omega S, tahu tak omega S? Equal to 1500 times 2 pi over 60. Okay, what do you get here?
157.08.
157.08. Okay, radian per second. So can you calculate your T max now? Boleh calculate T max tak? Okay, put all the value. Semua kita tahu kan value ni? Put all the value in the equation. And cuba calculate tengok. 3. Sorry bising sikit, saya work from home dan ada orang buat rumah pula kat sebelah ni. Okay. Letak je dalam formula ni. This formula you don't have to memorize because it will be given in the formula sheet dalam exam nanti. Oh, sorry. But you must know how to use the formula. Astagfirullahaladzim. Sekejap macam mana ni? Nak keluar balik macam ni. Okay. Berapa dapat? Dekat luar. Okay, T max berapa dapat? Anybody? Hello? Jawablah. Tidur lagi ke korang ni? So dapat 12526 Newton meter. Betul tak?
Betul.
Semangat sikit. Ay. Okay, sekarang value T max ni, is it lower or higher than T start? Marah lah ni. T start ni, lower or higher?
Higher. Good.
So T start ni dia lower lah daripada T max, betul tak? Berapa dapat value T start hari tu? Kita dah calculate. 102 point something Newton meter. Tengok balik nota.
102.54.
54 kan? So it's lower than T max, which is 125.26 Newton meter. Okay? So required starting torque is lower than T max. Okay, therefore, walaupun this motor didn't meet the requirement for the starting torque of the compressor, but it is lower than the starting torque of the compressor. So it is still suitable to use this motor to run the compressor. Alright. Next, apa lagi kita nak buat? So now we want to know the speed, the maximum speed. The maximum speed of the motor. And how to calculate this? You must calculate S max, okay, the maximum slip. So S max by using this formula equal to 5 over 5 squared plus R1, sorry. 2 squared plus 5 plus 5 squared. Okay, you akan dapat S max equal to 0.49. So from this S max, you can calculate the maximum speed, which is equal to 1 minus S max times omega S. What do you get for maximum speed? Okay, this is your maximum speed. 157.08 dapat dalam omega M, then berapa dapat dalam RPM? Cuba calculate. What is the maximum speed? Dapat tak? So dapat, kalau dalam RPM dapat 764.56 RPM. Kalau dalam omega dapat berapa ni? Dalam omega M ni dapat berapa? So make sure nanti kalau you do the calculation, you show all the steps and how you change from radian per second to RPM, semua you put in the calculation. Alright. Berapa dapat ni? Wahai murid-murid semua. Berapa?
60.11.
60.11?
80.07.
Oh,
8.
90.
Tengok, ngantuk cakap 80.11 11 77 ke 11? 80 point? 11. Apa-apalah yang calculate So nanti you check. Okay, so the speed at this T max, you get your speed, maximum speed equal to 764.56 RPM. Okay, so that's the recap on the induction motor. We have calculated the torque, the starting current, the maximum torque, the torque at rated speed, and also the speed, maximum speed, and the slip speed. Okay, the slip at maximum. Okay, let's look at back what we have learned so far. What have we calculated so far? Okay, this is the torque speed characteristic of the induction motor. So we have T rated here, T start here, where you start at 0 speed and M equal to 0. You have a rated torque. Then, you have the starting torque. Then, in the question, you are given the rated speed, which is here. It can be omega M or NM. Okay, so this is your omega M rated. Okay, at the rated torque. Tadi berapa dapat rated torque? Nanti kita buat kat sini So this is your omega S, which is your synchronous speed. Alright. And you have the pull out torque, which is T max here. And at this T max, you akan ada S max. Okay, S max, which is the maximum slip, and also omega max here. Alright. So kalau sini, this point is at rated speed. Alright. This is your induction motor torque speed characteristic. Alright. Now, kalau kita lukis balik kat sini, based on what we have done, maybe dalam question katakanlah dia suruh lukis your torque speed characteristic, lebih kurang macam ni, and put all the values. So what do you get? What do you get for your T max tadi? T max, kita dapat 125.36. Betul? Meter. And berapa dia punya speed? Letaklah kat sini nanti. 764.8. Okay. This is RPM. Betul? And what is the starting torque yang kita dapat previously? T start is equal to 102. Apa tadi? 102 apa? Saya pun kena buka balik nota saya ni. 54. Okay, this is your starting torque where your speed here is equal to 0. And you also calculated for the rated torque. Yang ni 1500 your synchronous speed. Okay. NS. Okay, you also calculated for the rated torque at the speed of 1370. So this is your Nm rated. Okay, so your torque here, the rated torque. Berapa dapat tadi rated torque? Berapa dapat rated torque? Hello. Berapa saya nak? 48.29 kan? Kat sini. Okay, this is your rated torque. So you ada maximum torque, your starting torque and rated torque. So how to calculate your slip? Kalau nak calculate slip is equal to NS minus NM over NS kan? Betul? So this is your NS. Okay, this is your slip. Okay, slip is the difference between the synchronous speed and the operating speed. So kalau ini, this is the calculation for the slip at rated. Okay, kalau slip at starting, tengok dia besar slip at starting, 1500 minus 0. Okay, dapat starting, the slip at starting. Okay, so this is how to label your induction motor characteristic, and we already calculated all these values previously. Okay, so kita dah dapat semua this value, then you dah tahu dah how to apply, which formula to apply in order to calculate for all this value. Boleh faham ke up to here?
Boleh.
Ke banyak sangat? Boleh? Okay, Alhamdulillah. Okay, so this is the end of torque speed characteristic for the induction motor. Okay, apa ni? Okay, this is the explanation on the torque speed characteristic. So, kalau kita ada motor, nanti kita pun akan ada satu lagi the characteristic for the load. Dia akan intersect with the torque characteristic. Later we will learn about this. And this torque speed characteristic shows how the induced torque varies with omega m, which is the speed based on this equation. Okay, based on this equation, 3V phase squared R2 over S, omega S, and so semua ni lah, impedance dengan resistance. So this omega S we can calculate by using 120F over number of pole. So this one given, but you must classify whether it is delta or Y connected, because usually it will given V line. But in this case, we want to calculate, we want to use V phase. And this slip we can calculate by using this formula. Okay. Yang lain semua akan diberi except for NS minus NM over NS. Except for these three, you have to figure out or you have to calculate based the information given. Okay. In the torque speed characteristic, there are two parts, and one of these is the linear region part. Okay, this is the linear region operation where you have the small slips. What do you mean by the small slips? Tengok sini. Kalau you nak calculate slip, omega S ataupun the speed at rated, the speed of synchronous minus the operation speed kan. So kalau slip dia lagi kecil, lagi bagus lah. So this linear region, you have small slip, and in this case you will have high efficiency. Okay, kalau small slip, high efficiency, and this linear region also can dia lagi stable lah for motor operation. So basically kalau kita nak motor to operate, to run the load, we want it to operate in this linear region. So katalah kita ada torque, kita ada torque load characteristic, kita ada load kan. Kita nak load tu intersect at this linear region. Okay, tak mau intersect kat sini. Yang region yang non-linear region ni kalau kita intersect, dia akan efficiency dia very low. Okay, so kita nak dia intersect at this linear region because dia lagi efficient. Boleh faham? Apa-apa pun we want the load to run the load at the linear region. Okay. Okay, there are several types of induction motor. Ada class A and B, class C and class D. Okay, and different types of motor will have different torque speed characteristic. Okay, we have discussed later, itu lebih kurang dalam kelas A punya. Apa yang bezakan dia punya slope kat sini? Okay, for kelas A dia ada steep slope. For kelas D ni, the difference dia, slope ni dia lebih besar kat sini. Ya. Kelas D dia provide high starting torque. Okay, and wide stable speed range. Dia wide punya, dia punya slope ni wide, but it is low efficiency. So kalau nak pilih to use in the industry, we must choose lah whether nak high starting torque ke, but efficiency tak kira ke, or we want the high efficiency, we can choose class A, B or C. Okay, except for class D ni lah, dia low efficiency. And this already ada satu table on the notes, you can see what is the difference and you can read what is the difference between class A, B, C and D. Okay. Okay, we have looked through the torque speed characteristic of the induction motor. Dekat sini saja, in this region only. But actually the torque speed characteristic ada juga in negative region, where we know, we call this as generator region. And we also have some part on the braking region. Okay, previously kita tengok kat sini je. Okay, the motor region, where we have T-max, which is the pull-out torque. But in generating region also we have T-max juga kat sini. Okay, which is in the negative region. Okay, generating. And the synchronous speed is still the same. Okay, so there are three parts of torque speed characteristic for the induction motor: generating region, motoring and braking operation. Okay, this is the detail for motoring region. The slip must be between 0 to 1 and the T in the induced is the same direction as omega m. Ini lebih kurang macam Q1 operation lah. You have a positive speed and you have positive torque. In braking region, the slip must be greater than 1 and omega m become negative and in opposite direction to the torque. So kat sini omega m negative, but the torque is positive. So that's why we name it as braking. It's different direction, yeah. So S greater than 1. In generating region pula, we have S less than 1 and the torque is in opposite direction to omega. So the torque this time is negative, but omega now is positive. Okay. And this region, the motor act as generator and it will supply back the supply to the electric, to the system. Okay, it will supply the power to the system. Okay, it act as generator. Boleh ke kat sini? So there are three regions, but we consider the motoring region. And later we see one example on the generator region. Boleh ke? Boleh, eh? Okay. Let's do another example. Boleh go on ke? Tak boleh go on lagi. Boleh ke? Kita proceed?
Boleh.
Boleh, eh? So we have another example. And this example I give in the, saya dah bagi dalam, apa tu? Telegram, yeah, you can look at in the Telegram. So kita ada same question, a 450 Hz 4-pole 1370 RPM delta connected squirrel cage induction motor have the same parameters. If the motor is required to operate under regenerative braking mode at rated terminal voltage and frequency, what is the maximum torque that it can supply and at what speed does the maximum torque occur? Okay, regenerative braking mode. Braking means the torque and speed dia tak sama apa direction, and regenerative means here lah generator, it generate the supply. Okay, generate. Okay, and braking means the torque and speed is not the same direction. So kat region, this region lah. So how to do this? which formula you want to apply. So all this formula memang dah ada in your notes, but you must choose and learn how to use the formula. Kadang-kadang bagi formula tapi tak tahu guna pun tak guna ya. So based on this regenerative braking mode, so you want to calculate at this region. Okay, at this region. So you want to calculate the speed, the maximum torque here, T max, but this time is negative, and you want to calculate the speed here, omega. Boleh? So for calculating T max, you'll be using this formula. It is the same formula, macam nampak sama as the formula for the motor region, but the difference is this part. Okay, instead of plus, dia minus. Boleh? Okay, instead of plus, dia minus. So the same speed. The same synchronous speed. Kita boleh guna synchronous speed yang sama lah sebab base it's the same motor. Cuma ni region of operation is different. So this is how you calculate the synchronous speed. Kita ulang-ulang supaya you lekat kat kepala tu. 120 times 50 over 4. So 1500 RPM. As long as you using the same frequency and same number of pole, synchronous speed will be the same, okay, throughout this problem lah, kan? Tak ada ubah pun pole tu dia. So now, apa lagi yang kita nak? Ini dah synchronous speed, you kena change to radian per second. To calculate, you ada V phase dah ke? Ada ke? So V phase will be equal to V rated lah. Ya?
Betul.
400 volt because it is delta connected. Okay, now put all the values in this equation and please calculate for T max. Boleh tak buat sekarang? Kita ada beberapa minit lagi ni. Tak apa, nak habis dah, cepat-cepat. Nak habis dah ni. Sekejap lagi boleh rehat. 400 squared over 2 minus 2 squared. Betul ke? Betul. 5 plus 5 squared. What do you get? Sini je yang ubahnya. Instead of plus, dia ada minus kat sini.
Negatif
Apa dapat? Ya, negatif berapa?
186.37.
Okay, thank you. Negatif 186.37 Newton meter. It is negative because it's in braking. Okay, braking of generating side. Okay, kat sini. Sebab tu dia negative torque dia. Okay, now we want to calculate for the speed, the maximum speed. Okay, this is the formula, and in this formula, you must have S max. And how to calculate your S max? By using this equation, ya. S max equal to minus. Dia ada minus kat sini. The difference only minus. Sorry. 5 2 squared plus 5 plus 5 squared. What do you get for your S max? Apa dapat?
Negatif 0.49.
Macam sama tak yang kita dapat tadi for S max? Yeah, it's
Sama.
just the same. Except for this negative because this is the same slope. Yeah, same slope. Sebab tu kita dapat S max dia slope dia sama. But it is negative lah sekarang. So dia same but negative because the same slope. Okay, now we can proceed with calculation the speed. Okay, the speed at braking T max. Okay, so omega M max equal to 1 minus 0.49 times 100 darab 2 pi over 60. Okay.
Doktor.
Ya.
Dia jadi tambah lah kan sebab negatif-negatif.
Ya. Okay, sorry. Okay, tambah. Berapa dapat?
234.05 radian per second.
Okey. Kalau 234.05 radian per second. What about in RPM? Boleh nampak tak saya tulis ni kan?
2235 ke?
Okey, 2235 RPM. Okey? Boleh nampak tak? Saya tulis kat sini lah. So based on the calculation, Nm max equal to 2235 RPM. Okay. So, this value, is it less or greater than the synchronous speed? Synchronous speed kat mana? Kat sini kan? 1500 RPM. But now, because it is in generating region, the omega max now is greater, okay? Greater than omega s, or Nm max is greater than the synchronous speed ns, okay? N max greater than ns, okay? Because it is in generating region. So, the speed bigger than the speed is bigger than the synchronous speed sebab dia punya S max ni negative. Okay. So I think that's the end of torque speed characteristic. And tomorrow we will go into the speed control of the induction motor. Boleh faham ke sampai sini?
Faham, Doktor.
Faham. Okay. Saya dah ambil attendance kan? Okay, sekejap Okay. So, please write what you have learned so far today and one thing that you don't understand, if any. Okay, ikut-ikutlah ada yang tak faham. So, tulis je apa yang awak dah belajar so far. Sama ada hari ini ataupun last week. And apa saja one thing that you don't understand, one thing ke two things ke pun tak apa. If you don't understand, sama ada topik hari ini ataupun previous topik. Okay, please write down so that I know kat mana you yang tak faham, kita boleh stress on that topic. Okay, boleh tulis tak? Okay, yes. Delta OY itu kena make sure betul-betul sebab it based your phase voltage will be based on that. Okay. Ni more. Tulis je apa yang dah belajar, apa yang faham tulis je. Nanti lagi faham. Maximum condition. Okay. For the induction motor, for the torque speed characteristic punya analysis is quite macam simple sebab you have the formula to use. Okay, you have the formula to use, but you must make sure the formula yang you nak guna tu must be a correct formula. T-max formula, it can be either positive or negative based on the region of operation. Okay, kalau soalan tu kata motoring region, so you can use yang without the negative lah. Kalau dia kata regenerative braking region, means that it's generated power back to the source. Itu T-max tu nanti formula dia yang negatif tu kan. Yes, three type of torque speed characteristic. Yes, motoring region, generating region, braking region. So we have done the motoring region on the first example and generating region on the second example. Okay, any more? Ada yang apa-apa yang tak faham? Okay, hopefully semua faham ya. So I hope all of you semua dah faham what we have learned so far and what we have learned especially today. And tomorrow we will continue with the induction motor and we will do one more example. Nanti saya bagikan example tu. So insyaAllah we meet tomorrow and thank you so much for coming. Okay, that's all.
Thank you, Doctor.
Thank you,
Have a nice day.
Bye.
Thank you,
Have a
Doctor.
nice day.
Thank you, Doktor.
Bye.